Welcome back to Sipa's Premier Garage. This time we will continue on this 300 HP NA project. This is mostly how I left this in the previous episode. If you haven't watched those, I recommend watching those first and then continue on this one. But anyways, I've only bought like some smaller bits and pieces back to this engine. And most of the time I've spent to like decide what to do with the cams and then to like get all the parts and stuff like that I need. But anyways, I now have the cams here. But well, maybe we first check like what is the cam availability for these BMW dual vanos engines, like the M52TU and M54, and then let's check what I have and continue the build from there. Here are the cams that I know are available for dual vanos engines. There isn't that many manufacturers for cams. I think the CAT cams are the only ones that are like new cams, and these other Schrick and D-Plus, I don't know how to say that, those are regrind cams. But anyways, the stock ones are 228 degrees on intake and exhaust, and even these M54P30 cams, the intake is 240 degrees and 9.7 millimeters of lift. So even this is quite good upgrade from P28 stock cams, for example. Like my E39, it has the M54P30 intake cam, and it already makes like 240 horsepower with this cam only. So this is already quite good upgrade. These I know these can make like 250, even 260 horsepower in good day. And then from these other ones, I don't have really experience how good these work. But anyways, these are the cams that are directly available for these engines. And these are the cams that I did end up with. These are stock M54P30 cams that has been regrind by Mauri Virtanen from Kylmäkosken Moottorikonestamo. My Finnish viewers probably know him. He's quite well known. And these were really cheap. Of course, these cams, I got these from eBay for maybe 100 euros, so really cheap. I don't think you can get these anymore that cheaply, but anyways. And then the regrind was less than 400 euros. So let's say 500 euro cams for me, so quite cheap. Let's see how those compare for the other cams I had on this list. And the regrinds that I have, they will drop in here, so these are a little bit more aggressive than these CAT cams. So yeah, not the most aggressive cams you can get for these engines, but the plus side is that again these were cheap, and I can just throw this in without any other changes. I did of course get the new lifters, mostly because the old lifters were really pitted and I don't know if those could have worked or anything. And also with all the better cams like these, I recommend to change in the lifters, so that's good thing to change. But anyways, I can just throw this in and this should work. In stock engine, here I need to check the valve clearance because I have the quite special setup. But anyways, these are something like, in stock engines, these are like something like 250, maybe 260 horsepower cams. So quite far away from our goal. But of course I have the really high compression ratio, E85, worked head, worked valves and everything. And combining all those, we should get quite close to 300 horsepower, how I'm imagining this will going to be. And of course we can also, because this is dual vanos engine, we can play around quite a bit with the cam timing. Because with cam timing you can move the power band up and low. And because with the dual vanos we don't need to be that careful with the losing all the low end, because we still have the vanos movement of the cams. So in that way, decreasing this cam something else like stock, I think we can gain some power there also. And my goal is to like check with these cheap cams where we end up with the power goal, and if it's like still like 260 with these, I know that I need to get really aggressive cams and probably solid lifters and valves and everything. So I mean valve springs and everything, so that will be really expensive. But then of course if I'm sort of like 10 horsepower, I think I can just get those Schrick cams or something, and that should work out much cheaper. So this is just my way to check with these cheap cams where I will end up with the power goal, and maybe don't spend just in case too much money on the cams. I will probably get my money out of these when I'm selling these cams, if I will sell. I don't think these will make 300 horsepower with all the chains. but I'm pretty sure this will be really close with these ones, or at least I'm hoping so. And there's of course, because this is NA engine, there's a lot of tuning we can do with the intakes and exhaust and cam timings and everything. So that will play a big role with these cams. These are not just brute force cams that you can just throw in and get a lot of horsepower. But yeah, maybe stop the talk and install these. I need to get the engine back from all the junk there, and I've cleaned all this, but let's clean these cam caps once again and put in with the new lifters, and then clean the one-hose unit and assemble that, and then we can get to the cam timing and stuff like that. So yeah, let's stop the talk and just get working. Let's throw in the lifters first. I have new Kolben-Schmidt ones. These are OE. I usually use the ENA ones, but these Kolben-Schmidt ones, these are also OE. And why I have these? The reason is that these were at the moment cheapest ones that I could get. And when putting back these cam trays, be careful to line these on the correct sides. The top caps, they have the ENA marking the exhaust and intake, but these don't have any marking, at least I don't know, but you can tell from this oil groove here. So this exhaust one, it has the feed on the middle, and the oil goes through here and then to the other side, and I think the other side gets the feed from here like this. So if you mix these up, there's no oil flow at all on the exhaust side because there's no oil hole here, and also same on the intake side, so you will pretty much have no oil flow at all for the cams and the lifters or anything. And when you do that, I have seen that many times, it's not pretty when that happens, so don't do that. Check that you have these oil grooves and on the correct sides if you're not sure which side is which, because you can tell from these easily. Now to continue, I need to assemble this Venus unit. This was pretty rough looking, but I did take this fully apart, clean everything, blow all the holes and everything. It's not like new looking, but at least it's clean. And even though it looked really bad when I cleaned this, this looks like it's in pretty good condition. These are like shiny everything. I did try to polish this, but I don't think I did much there. But yeah, if you see that these are shiny like this should be fine. Usually shiny parts are a sign of wear, but in the so this kind of shiny surface is what you are looking for. Then I have box full of parts here. I have some new parts, some old parts, new seals from Patience Systems. These are the best ones that you can get. You just only need to replace these ones and that's it. So really good quality ones. Yeah, I think I should have all the parts here. So let's put this back together and then we can continue with the cams. Okay, time to set the cams. I have already checked that there's enough valve clearance with this kind of setup that I have. I know that these cams normally have enough clearance, but because this is a special setup on the bottom end. So basically did just set the cams how I will do here now, and then check how much room there's to open for the cams in both OSS, both advanced and retouch settings, in both TDC and minus and plus 10 degrees on the crank, because those are usually the tightest spots. Basically I just set these cams to every position that I wanted, move the OSS and so on, zero out the dial gauge, just a sec. This one here. So basically every time I did set the cams and the OSS to correct positions, I did zero out this dial gauge and then unlock the timing and try to move the cams to see how much room there's for the valves to open before they hit the pistons. This is not the best way to do this. You need to be really careful not to bend the valves when you try to move the cams, but that's how you can do that. You basically, when you zero this out and move the cams, you can immediately see how much room there's for the valves to open. So this is quite easy to do when everything is together. Just need to be careful not to bend the valves. And that's what I did. I think in the intake side, the tightest spot was the 10 degrees after TDC and Vanos fully, is it advanced or retard? I don't remember. Anyways, there was like 2 millimeters of room, so there's plenty of room to get better cams or different timing or something like that. In the exhaust side, again the tight spot was 10 degrees before TDC and Vanos fully turned. I need to check which direction it is. But anyways, there was like 1.5 millimeters room. That's enough, but there's no really room for better cams or something like that. So in case of this needs better cams, like it probably will need, the movement of the exhaust funnels, that might need to be limited or something like that. But anyways, we can now remove this dial gauge because I don't need that anymore, and also remove this one. And by the way, I'm checking from the number 6 cylinder, because when the engine is the TDCs and these are in the correct position, like these holes pointing upwards, then you can check the valve openings at TDC on this number 6 cylinder. Not the one, the number 6. But okay, finally set the cams. I have been asked many times to tell how to set these dual Vanos engines to degree the cams or anything. So I will first show how to set the cams when you have everything stock, and then I will move this how I feel this engine needs to be. But anyway, let's first do the stock one. So for now I have these, everything is really loose, so everything here can move like this. Nothing is really locked down yet. Engine is now at TDC, and I will pull these Vanos cups as forward as they come, like this. That should be enough. Then I need to set the cams. You can use any piece of flat iron like this, so that to turn the cams so that there's not any gap here. But there's also some tools that you can use. So for example, I have this kind of 3D printed things here. So put these ones here and turn the cam until this is flat. Like that. Exhaust side is flat. Then same on the intake side. Okay, that's now there. These have places to put some bolts and anything here, but well, that's fine. That's plenty enough for this. Let's go back to the front side. Okay, now that everything is loose here, we will grab the Vanos unit. In this, the intake side needs to be as far in as it goes, and the exhaust is far, well, actually other way around. The intake is like as far out as it will go, and the exhaust side is as far in as it goes. But now we can push this in like this, and we should see that the Vanos unit will push these cups here inwards toward the engine, like that. Carefully. Okay, and now everything should be set in the correct position. I will carefully loosen this one, like this. That's okay. Now we can remove the Vanos unit. And we can now lock the timing. These 3 Torx bolts here, these will lock the timing. So carefully get these started. Like this. You can also tighten these ones now. And now you can grab the torque wrench and tighten these to the correct setting. I would also use spanner to keep the cam from moving. But after tightening these, all these, so these three ones here, and these torque ones here, then you should be set with all the timing. So you can reinstall the Venus unit. So put this on with the gasket, of course. Like this, and you are pretty much set. So now the engine would be timed correctly. You can remove the locks from the behind of the engine and rotate this engine a couple of times to make sure. But that's pretty much it. So it's nothing special really. But I will do a little bit different timing. So that's why I didn't torque down those yet. Let's remove this Venus and adjust the cams a little bit. Okay, back to start. I have everything at the base position. Normally, if you would want to move the power band up higher and make more power, you would advance the exhaust cam, meaning that it would be open more at TDC. But as I said, when I did measure at the other end of the Venus travel, it was pretty close. It was like 1.5 millimeters from hitting the piston. So I cannot really move this exhaust cam. That's how it is now. And usually the changes from the exhaust cam, those are really minor. So let's leave it like this. But then on the intake side, in here you would retard the cam, so less open at TDC to make more power at higher end. So that we can do because that's making the valves even more far away from the piston. So that's fine. So I don't know how much, it won't be much because in stock M54P30 the cam map it's like 6500 RPM and it's 126 degrees around there. So a few degrees more it would be fine with 7500. I don't know how much these different cams affect that, but let's try to move this little bit. I don't really have any way to measure, so I just gonna wing it. So let's do that and retard this little bit, so less open like this. Maybe I will put this here and I know that. Yeah, so if I need to re-degree this again to same setting, I know that if I have the this one here, it's fine. I can see the actual degree when the engine is running from the ECU logs, so that's fine. I can then tell what it is the actual setting. And of course, when we do the first logs, we can see the base setting of this, but when we do pulls and that kind of things, we can see what kind of cam timings would be maybe better or worse than it is here. So this is just the first setting I will try out, and then based on the logs, we will degree this again differently. But yeah, we'll go with this first. And well, that's all from the cam timing. I will throw back on the Venus unit as I did so earlier and actually lock the timing correctly here with the torque wrench. And yeah, I think we can then throw back all the stuff I have now for the engine and it will be ready for the car. Jointing torque for this is 5 Newton meters. That's it. And 20 Newton meters to actually torque this down. These are 10. These are 8 Newton meters. Note that these are reverse thread, so not all torque wrenches can work in reverse direction. This one that I have can work, so this is fine. It's just really strange to tighten these wrong way. But yeah, that's 8, it's not much. Same for the other. Now let's remove those locks and we can rotate the engine a couple of times. Okay, it's back at TDC, so double check the cam timing once again. Exhaust is fine, and the intake. Come on. Yeah, intake is fine, so let's continue. And finally, let's seal this up with brand new valve cover. This is aftermarket one, mainly because the used original ones, they were much more expensive than this aftermarket one. This wasn't like the greatest quality. I tried to paint this because the surface was horrible here. Otherwise this seems fine, but again I need to paint this and it still isn't perfect, but yeah, that's fine for me. I'm not building this engine for looks. I'm building this to make some power. And wait a minute. Again, almost forgot. This one needs to go on. This is always something that I will forget, and I know many will forget. I need to. There's some dog hair here, so I need to clean this, and then there's some oil here, so I need to clean that too. But yeah. And it's finally done. Well, it's not done, but it's ready that I can drop this on the car. I did check that this took pretty close to 4 years to complete, so yeah, it's a long time. But this isn't my main project. This has been like in back burner. But yeah, it's done. Next up is to do the wiring and drop this in the car, and I think the wiring will be the next episode. Next up is to do the wiring and drop this in the car, and I think the wiring will be the next episode. And I have decided to change the ECU that I will run in this. You can try guess that in the comments, so it won't be the Speeduino, mainly because I was planning to do the drive-by-wire support for Speeduino, but I didn't have time, so I want to run drive-by-wire in this one, so the ECU will have that. And yeah, you can see that I have the cover for the pencil coils, so that might give some clue that what ECU I will run. But anyways, let's do the wiring in the next episode and then drop this in the car. I might drop this in the car even before I will get the wiring done, but anyways, the wiring will be probably with the next video, how to convert wiring from this engine to E36. Let's end here and let's hope that the next video will be out really soon.